Akash or Bhavya?
Bhavya.
Okay. DIY projects or ready-made projects?
Do-it-yourself projects any day. If you are buying projects from Janak Puri, you have failed as an engineer. I'm saying this straight up to everybody. I do not care if you're studying for whatever entrance exam, you're studying for CAT, you're studying for GRE, you're studying for GATE. If you are not making your own projects, find your projects, you have failed as an engineer. Do the thing or what you're studying. Don't just leave it on paper. Even if you design it on MATLAB, do it. If you are able to find time to actually make a PCB, if you're able to find time to actually debug it, write code for it, understand what you're doing, do it, because that is the only way you'll actually learn the actual way of that engineering is done.
So, Soham, tell us, how does the current job that you are presently working in makes use of the skills that you learned during the 4 years of your UG?
Okay, all right, that's a very good question. So, one of the main things that you learn on your first year at any job is that whatever you studied in college, you will not be applying it at your work. What do I mean by that? By that I mean that in college they teach you a lot of different things, but they really don't teach it to you from the point of application. Like for example, we triple guys, we have studied analog electronics, we have studied digital electronics, we have studied three subjects of power electronics, right? We studied power electronics 3 times. We studied power electronics, we studied electrical drives, then we studied this thing, your flexible AC, जो facts वाले systems होते हैं, right? So we studied power electronics these many times, but you ask any triple student who has not actually designed his own MOSFET driver that, okay, you have got something called as a MOSFET driver, but what is a MOSFET driver? How does a MOSFET actually switch on using the driver? What is high side switching? What is low side switching? That is something you'll end up spending a couple of weeks on alone, because this is something that is not taught in college at all. So what actually college teaches you is how to learn, right? So no employer expects you to know everything right on the day of your interview, because if you would already know that, you'd be applying for a senior engineer's post, not a graduate engineering trainee, right? So if you already had that information, so nobody expects you to know everything on your first year, but what you should know is how basic semiconductors work. You should know how a diode works. You should know KVL, KCL, ये सारी चीज़ें कैसे काम करते हैं. You should have a rough idea of how transformers work. So a basic idea of how programming works. Okay, so if you're going into a firmware design, then you actually need to study quite a lot, because they actually expect you to know these things before you join. So firmware may you need to have like at least some knowledge of how different registers work, register level coding. Not only Arduino is a good starting point, but you should understand how the architecture of whatever microcontroller that you're working with, how the architecture works, how different registers interact with each other, how do the timers work, how do the PWM work, and how do different interfaces work. So those are things that everybody should know. You should also, from the hardware point of view, you should know how a MOSFET switches on. If you just study this one question, it'll clear up pretty much all of your power electronics. Just this one question, how a MOSFET switches on. That is a good starting point. If you design your own buck converter circuit, which has got a feedback as well. Okay, did my camera just freeze? Yeah, okay, I think I'm back. Okay, cool. Yeah, so what again, like all of my advice on anything related to engineering in college is do it. Do the thing or what you're studying. Don't just leave it on paper. Even if you design it on math lab, do it. If you are able to find time to actually make a PCB, if you're able to find time to actually debug it, write code for it, understand what you're doing, do it, because that is the only way you'll actually learn the actual way of that engineering is done. Learn how to read data sheets. That is one of the biggest things, like that is one of the first things that I learned in at work, because when you're in college, sheets are like, okay, maybe you study one data sheet, two data sheet, three data sheet, maximum 10 data sheets. But when you're at work, you're expected to read a data sheet and literally understand how everything works in that particular circuitry. So that is another skill that you should pick up when you're in college. So yeah, the thing I was talking about, a buck converter. So if you are able to design a buck converter on your own using any microcontroller, do not use Arduino. Use like, even if you're using an Arduino's hardware, code it using embedded C, code it using Atmel Studio instead of using Arduino. So that way you're actually able to go inside register level. You're able to design a digital control loop, like all this control theory that we study. In real life, it does not work like that at all, because in real life, no analog system is sitting and controlling how the loop is working. It is all digital control. So studying how Z transform and different digital control works. So just one project of making a digitally controlled buck converter will make you, I would say, equivalent to a power electronics engineer who has been in the industry for maybe 1.5 years.
Great, Soham. So now we move on to the most interesting part of the series, that is the rapid fire. So let's go on with the first one. So the first one is explore different verticals or stick onto one field and grow.
I would say explore different verticals and then stick to what you enjoy.
Okay. The next one is which version do you like the most? Soham as a engineering freshie, and the version 2 is the present day Soham.
The present day Soham. Soham back then was very naive, and he thought that okay, he could pretty much study up anything overnight. But now I realize that okay, you can do that, but that's at the cost of health. So
Hmm. Okay. DIY projects or ready-made projects?
do it yourself projects any day. If you are buying projects from Janakpuri, you have failed as an engineer. I'm saying this straight up to everybody. I do not care if you're studying for whatever entrance exam, you're studying for CAT, you're studying for GRE, you're studying for GATE. If you are not making your own projects, find your projects, you have failed as an engineer.
The most interesting one, Akash or Bhavya?
Bhavya.
Okay. You won't prefer any advice over there, right?
I mean, like, see, I never studied the answers from either of the books, right? So, I really do not care that there were misprints in the answers. I used to treat. Okay, so this is a general advice to all students of IP University and basically any university in general. The way to score well in any exam: study the last 5 years of papers that have come in your university or similar universities in the same subject, and do not just stick to those questions. write down what topics are they coming from, and then put extra effort on those topics. So if you study those questions and those topics, you're getting above 80 straight up. And then if you're doing further research, if you're studying the extra topics as well, which are there in your syllabus but ज़्यादा questions उस topic से आए नहीं है, then you are reaching towards the 90 range. So Bhavya, Akash, they really were equal to me, because like last moment studying, theek hai, in that stress Akash is better straight up. But Bhavya was the first series of books that I bought, and I guess you can call it brand loyalty. I just stuck to them, although I know that बहुत printing mistakes होते हैं उनमें, and you'll be banging your head against the wall if you try to study the answers from there. So do yourself a favor, just read the questions, then find the answers on your own.
Okay, moving on to the last one, CGPA, internships or projects?
I will say that depends upon what you're going for, but like I would say projects would be the most important one to develop your own skills. But if somebody tells you that CGPA does not matter, do not listen to that person's opinions, because that person is straight up lying to you. CGPA matters. Have a good CGPA. Do not just think that okay 7 के ऊपर है and I'm happy with that. Aim for higher. The higher it is, the better it is. It is not difficult to score in college. थोड़ा पढ़ लो यार, number मिल जाएंगे. It's not that difficult. Seriously. This is coming from a slacker who pretty much wasted his first 2 years in engineering. So पढ़ लो यार, हो जाता है, number मिल जाते हैं. Do your projects, focus on that. But if you also follow the studying tips that I gave before, number आ जाएंगे, you'll be good. So CGPA, and so first I would say projects, then I would say CGPA. Internships, they're a little bit hit or miss, because mostly, unless like you have got any specialized skill set, they're just going to treat you like it's babysitting.
So that was great talking to you, and definitely it was a very fun session with you, and hopefully your words had a very deep impact. I hope that it leaves a very deep impact on our viewers, and maybe we hopefully get to see full-fledged engineers coming up soon in the market.
Hopefully, man, hopefully.
So all the best with your studies, Soham. I hope to see you as a AI expert, and I'm looking forward to see your inventions. A unique blend of power electronics and AI. That's what you were mentioning.
Yeah, let's see how that ends up going.
Great, Soham. All the best, and thank you for taking some time out of your busy work life and study schedule. I must say.
Sure thing, man. Sure thing. It was really fun interacting with you, and great time, man. Great time.
Thank you, Soham.
Anytime, man.
Have a great day.
You too,
Bye.
man. Bye.